Okay, hello. This time I'm going to explain section 4.3 of calculus, which is about monotonic functions and the first derivative test. So there's 20 problems on the homework assignment, and I'm going to go most of them. So first question, answer the following questions about the function whose derivative is f dash of x is equal to 3x times x minus 2. So we have a function f dash x is equal to 3x times x minus 2. Part A. What are the critical points? What are the critical points? So the critical point is the point where the derivative becomes 0 or where the derivative is undefined. Now this is a quadratic function, so it is defined everywhere. So we just need to find for which value of x the derivative becomes 0. And since this one is a factored form, it's easy to find that x must be 0 or x is equal to 2. Okay, so the critical point is x is equal to 0 or x is equal to 2. Now let's move on to part B. On what open intervals is f is increasing or decreasing? So now I'm going to check whether the derivative is positive or negative. I'm going to create a table, 増減表 for f dash and f. The key point, the critical point in this case is 0 and 2. So the smaller one is 0 and larger one is 2. So I have 3 intervals to check. First interval is negative infinity through 0. The middle interval is 0 through 2. And the right interval is 2 through infinity. We know that those 2 points is 0. The slope is 0 at those 2 instances. Now, how do we check? How do we find functions increasing or decreasing? So that's the first derivative test is. First derivative test says if f dash is positive, then f is increasing. And if dash is decreasing in the interval, then f is decreasing in that interval. So I'm interested to know whether the derivative is positive or negative. Now look at the f dashes. F dash is actually a quadratic function. So it looks like this. This is what f dash is. And it becomes 0 when x is 0 and when x is 2. So from looking at the graph, the function is negative when x is between 0 and 2. And the function is positive when x is greater than 2 or when x is less than 0. So by looking at the parabola, it's kind of easy to see it's kind of changing from positive, negative, and positive. So by using the first derivative test, when the f dash is positive, the original function is increasing. And for the interval which f dash is negative, f is decreasing. So to answer this question, on which open interval is f is increasing? So f is increasing on negative infinity through 0, union 2 through infinity. Okay, well, actually, I was making lots of mistakes in this program. You see, I got a red mark here. So this is it because actually I had to follow this rule. Use a comma to separate answers as needed. So the Pearson wants this interval, comma, this interval. Okay. Now, if for f is decreasing on this interval. So it's 0 through 2, open interval. Okay, 0 through 2. Now part C. At what points, if any, does f assume local maximum and local minimum values? So local maximum is the point where the function is highest in that neighbor, in that local. And that happens at the critical point when you have a changing from increasing to decreasing. So at this point, you see the graph is increasing, change to decreasing. So this is gonna be the local maximum. And changing from decreasing to increasing, that's the local minimum. We do not have an endpoint, so we are not going to check in this case. So local maximum happens when x is equal to 0. So it's just asking for x value that get the local maximum. So the answer is x is equal to 0. And the local minimum is when x is equal to 2. So this question is not asking for what is y value at those local maximums, but if it is asked, we have to find what the original function is. In this question, we really do not know what the original function is yet, so we cannot answer what this value really is. So we don't know what this is. Okay, now I'm gonna move on to next question. So the problem is about the same, but with a different derivative functions. So problem number 2, the same question, but starting with a different derivative. Okay, part 1. What are the critical points? So the critical points is where that the derivative becomes 0 or undefined. This is a linear function. It is well defined everywhere. And this is exponential function, which is also defined everywhere. So the f-x is defined everywhere. So the critical points happens when the derivative becomes 0. Okay. And in this factored form, derivative becomes 0 if x plus 3 is equal to 0 or e to the negative 2x is equal to 0. This happens when x is equal to negative 3. And this never happens. This never happens. E to the something, exponential function does not become 0 at all. So the only critical point is x is equal to negative 3. Okay. So the critical point is only x is equal to negative 3. Now move on to part B. I am going to draw the increasing decreasing table for this function. Okay. First of all, domain for this function is all real numbers. Yeah, all real numbers. So it's like negative infinity through positive infinity. And the only key number you're gonna have is the negative 3. At negative 3, the derivative is 0. So now the number line is split into 2 sections. So one section is between negative 3 through infinity. And another section is between negative infinity through negative 3. I am going to check whether it's positive or negative. Okay. Now, graph of this one is not so easy. Graph of the f dash is not easy at all because you have a linear function multiplied by exponential function. However, this part is, this is always positive, no matter what value of x is. This is always positive. That means the plus minus sign of f dash depend on this part only. So f dash is positive if x plus 3 is positive, and f dash is negative if x plus 3 is negative. So, well, if you kind of think about the y is equal to x plus 3, its graph looks like this. So if you put any number greater than negative 3, it's going to be positive. And if you plug in any number below negative 3, you're going to get the negative values, negative y values. So the answer is so positive here for any number greater than negative 3, and negative here for any number below negative 3. So the graph is decreasing in this interval and increasing in this interval. So the answer to part B, function is increasing on this interval, negative 3 through infinity, and decreasing on the interval, negative infinity to negative 3. Now, does it have a local maximum? It does not have a local maximum. Local maximum must be like a mountain here, but in this case, you only have a local minimum. So the answer is, there's no local maximum. And the local minimum appears. Here's a local minimum, here's a local minimum. Local minimum appears at this point when x is equal to negative 3. Okay, so the answer is the function has a local minimum at x is equal to negative 3. Okay. Now we cannot see what the y value of the local minimum because we don't know the original function in this case. So we don't know what this is. Okay, number 3. I'm going to go quickly because it's the same problem, but just a different function. So you now have a derivative is 2 minus 18 over x squared. And the domain is all real number except 0. You see that this function is not defined when x is equal to 0 because the denominator becomes 0. Anyway, to find the critical point, I need to find for what value of x this becomes 0. Okay. And this becomes 0. Well, if you rewrite this one, it's kind of easier to see. So multiply top and bottom of the left side to do the fractions, subtractions. And we are going to solve for this. Numerator can be factored like this. Okay. Now you can see that the derivative becomes 0 if x is equal to 3 or when x is equal to negative 3. So the critical points are x is equal to 3 and negative 3. F dash x is undefined when x is equal to 0. But x is equal to 0 is not included in the domain. So we are not going to consider this as a critical point because first of all, the graph does not exist at that point. Okay, now part B. We are going to draw the increasing, decreasing table. It's gonna be longer. Now you have a negative 3 and a positive 3 as a critical point. But also, this is gonna be important. Because the graph is kind of undefined at x is equal to 0, you should include this one as well. Now, the derivative becomes 0 when x is equal to 3 and when x is equal to negative 3. And f dash is not well defined when x is equal to 0. And f is not also defined at x is equal to 0. Okay, that's a domain. Now I want to know for what value of x on which interval, in which interval, here's negative infinity through negative 3, here's negative 3 through 0, and here's 0 through 3, and here's 3 through infinity. So you have 4 different intervals to check. How do we check whether it's increasing or decreasing? You are going to check for what value of x this is positive or negative. It's a complicated fraction, but please notice the denominator is always positive. Denominator is always positive. So whether f dash is positive or negative, it depends on the numerator. And the numerator is just simply a quadratic function. So the numerator part is just a quadratic function with 3 and negative 3 as x-intercept. So you can see that it must be positive below negative 3 and positive above 3. And it's negative between negative 3 and 3. So plus, minus in between, and plus. So the graph gonna be increasing, decreasing, decreasing, and increasing. Now you know this should have a local maximum here, and you know this is local minimum here. Now let's answer the questions. Okay, what are the critical points of f? When x is 3 and when x is negative 3. Okay, on which interval function is increasing? Increasing on negative infinity through negative 3 and 3 through infinity. Okay, as the table shows. So once you complete the table, you should be able to answer these questions rather quickly. Okay. Okay, now a different question, number 4. So you have some function and find the open interval on which function is increasing and decreasing. So you have a graph looks like this. Like this. Okay. So it is decreasing, 右下がり, decreasing from here to here, negative 20 through negative 10. Increasing from negative 10 through 0. And it's decreasing between 0 through 10. And increasing from 10 through 20. Okay. So function is increasing between negative 10 through 0 and 10 through 20. And it is decreasing on negative 20 through negative 10 and 10 through 10, 0 through 10. Okay. Now identify the local and absolute extreme values. So I need to answer 4 questions. Local maximum, local minimum, absolute maximum, absolute minimum. Okay, so one at a time. So what is absolute maximum? Absolute maximum is a point which attains the highest y value possible. So in this case, this point has the highest y value. So this point will be the absolute maximum. Now, local maximum is the highest in that vicinity. So absolute maximum is also a local maximum, but there is also another local maximum at 0. Okay, those are the local maximum. Okay, so you have 2 answers. Now, absolute minimum is the lowest y value possible. So this has a lowest point at this point. So the 10, negative 15 gonna be the absolute minimum. Okay. So question is asking, if function has other local minima, where do they occur? So for this one, do not include absolute minimum in the list. That's what it said. So I should not include this one. Just try to find other local minimum points. So that's gonna be this This is it. So you just answer this point and then it's done. Okay, now next question. Find open interval on which the functions is increasing and decreasing. So the first part, well, where it's increasing and where it's decreasing. So it is increasing from -8 through -2. -2 through maybe 1 is decreasing, and 1 through 4 is increasing. 1 through 4 is increasing. And 4 through infinity, 4 through 8, it's also increasing. So you have 3 different intervals where the function is increasing. The function is decreasing between -3 through 1, -2 through 1. Okay. Now next question. Find each local maxima, if there are any, and select correct choice below and fill in any answer boxes within your choice. So you need to find local maximums. To find local maximums, looking at the graphs, the one obvious one is -2, 4, -2, 4. Okay. And another one is going to be this point. This point is when you're looking at its vicinity, when x is between around 4, this point has the highest value. So 4, 2 is also a local maximum. And another one is going to be the endpoint. We're assuming this is the endpoint of the function. So it's in the 8, comma 6 is also another local maximum. So you have 3 points, -2, 4, 4, 2, and 8, 6. Okay. Be careful about putting your answers. Okay. Now, next one, find the local minimum. Local minimums. So local minimums, I need to find each local minimums. So the first one gonna be this endpoint. This endpoint is kind of lowest in its vicinity. So -8, -2. Another local minimum would be this vertex here. This is 1, -2. This is local minimum. This one looks like a local minimum, but there's no point here. So 4, -4 is not included in the graph. So this is not considered as a local minimum point of the graph. So there are 2 local minimum points, okay, which is as this, okay. Now about the absolute maximum. Absolute maximum is the highest possible y value, which is 6 here. And that happens when x is equal to 8. However, this does not have a local absolute minimum. Absolute minimum is the smallest y value possible. And in this case, because the bottom point here is open circle, you really cannot have a smallest y value in the graph. Okay. If this is a black point, if this point is included, that's going to be the absolute minimum. But since this is open, you do not have the smallest possible value, y value. So there's no absolute minimum. Okay, now it's you have a quadratic function. Quadratic function. So g of t is equal to -3t squared minus 5t plus 4. And the question is for finding where it is increasing and where it is decreasing. So first of all, we are going to find g dash, which is -60 minus 5. Okay, now I'm gonna follow same thing as we did it in the first 3 problems, which is find the critical points. So critical point, what value of t this becomes 0? That's gonna be -5/6. That's it. So that's a critical point. So now the input value is t, and you have g dash and g. Domain is everywhere for quadratic function, and the critical value is -5/6. Okay, so this is a linear function with a decreasing line. So it's like a plus change to minus, plus, minus, plus, minus. Okay. So the graph is increasing here and decreasing here. Okay. So now look at the answers. So first question, function is increasing in this interval, -infinity through -5/6. And it's decreasing on this interval. Okay. Now part B, find the local maximum. Well, local maximum does not is actually this point. In the problem 1 and 2 and 3, we couldn't find this value because we only knew the dash function. We didn't know about the original function. But in this problem, we can find what the y value is by just plugging the t value corresponding to it. So I'm gonna put this one. So it's gonna be a messy computation. I had to do this. But after you do this computation, you're gonna get 73/12. Okay, so that's gonna be the local maximum, and also it is gonna be the absolute maximum. Okay, is there local minimums? There is not, because you don't have an endpoint here, and you don't have an endpoint here. So you really cannot have a local minimum point in this case. So does it have any extreme values? The answer is yes, because this gonna be also absolute maximum. So you're gonna have the same answer as in here. Okay. Okay, so this problem is basically the same as the previous question, but instead of quadratic function, you now have a cubic function. Okay, and if you know that the cubic function have a shape, you know that the parabola has a shape like this. And if you know that the cubic function looks like this or this, then you can kind of guess like what this answer looks like. But I'm not going to explain now. Okay, again, it's a cubic function, but I'm gonna explain this one, okay? So number 8. When you have a given function is 2r cubed plus 19r. Because I want to find increasing, decreasing of this function, I'm going to differentiate. It's going to be 6r squared plus 19. When, for what value of r, it becomes 0. So we want to find a critical point. So we want to know for what value of r this becomes 0. And answer to this question is, you just need to solve the quadratic equation. But if you see that this is like a graph looks like this, where it has no x-intercept, or the discriminant is negative, you know that this must be positive all the time. So because this is always positive, this is always positive, never becomes 0, so there is no critical point. No critical point. Critical point. Because this is always positive, always greater than or equal to 19. Yeah, when you try to solve the quadratic equation, you will see that 6r squared becomes -19, which cannot happen because this is always greater than or equal to 0, and this is negative. So no critical point is actually easy case. So now you're gonna make a table. R is a variable, and we are going to check f dash and f. And no critical point means I don't have anything to insert like this. We don't need to put anything. So you just have one big interval, and in that interval, the derivative is always positive. That means the graph is increasing everywhere. So this is kind of cubic function that is not liking having like a g's, but you're gonna have a cubic function looks like this. Okay, so it's increasing everywhere type cubic function. Now let's answer the question. For what interval function is increasing? It's increasing everywhere. And for what interval its function is decreasing? The answer is the function is never decreasing. Now let's look at the local maximum, local minimums. The answer is there does not exist any local maximum, local minimum. There's no absolute maximum, no absolute minimum, because you don't have an end point here, you don't have an end point here. So it keeps increasing forever, and it keeps decreasing forever in left and right. So it doesn't have anything. No local maxima, no local minima, no absolute maximums, no absolute minimums. Okay. Okay, now it's not a polynomial any longer. So I'm going to explain what's going to happen to this. So problem number 9. So find the open interval on which the function is increasing and decreasing. So we still have a same thing. You have some function. And I want to find critical points. Now, when you see the function has fractions or radicals or log, then you must be careful about its domain. Okay. So if these exist, you have to be careful about the domain. When you have a square root, inside must be non-negative. Okay. So domain is any x that satisfies this equation, inequality. Okay, so that x squared must be less than or equal to 18, and that means x must be between 3 square root of 2 through positive 3 square root of 2. So that's going to be the domain. Okay, now let's differentiate this. So remember, this is a product of two functions. So I have to use a product rule. So f dash g plus fg dash. 左微分、右。plus 左 times 右微分。右微分 gonna be something like this. Let's simplify this expression by making the fraction denominator the same. So you multiply left the top and bottom by square root of the same thing. So you want to get 18 minus x squared. And here is x times minus x. So it's going to be minus x squared. So that's going to be reduced to, that's going to be like 18 minus 2x squared on the top, which is minus 2x plus 3x minus 3. Factored form is better because you can find the critical point quickly. Okay, where's the critical points? So g dash becomes 0 when the numerator is 0. Okay, so the critical point is x is equal to plus minus 3. Okay, so denominator, well, this function has a denominator, and the denominator is basically non-negative, but it could become 0. So the g dash is undefined when x is equal to plus minus square root of 18, which is square root of 3 square root of 2. So those gonna be also the critical points because g dash is undefined. Okay. Now let's check the function is increasing or decreasing by drawing the table. Okay, Now this function you have to be careful about the domain. So you have a left endpoint this time. You have one critical point here, another critical point here, and you have a right endpoint. Okay. So the derivative is 0 here and 0 here, and the derivative is undefined at these 2 points. Okay, how do we check it's increasing or decreasing? So you want to know when this is positive and when this is negative. In this open interval, the denominator is always positive. Denominator is always positive. So the positive or negative of this function, it's all depend on the numerator. And again, numerator is just a parabola in upside down parabola with x-intercept is -3 and 3. So the slope changes, its sign changes at -3. It's like negative, positive, negative in order. It's going to be negative, positive, negative. The original function is decreasing, increasing, and decreasing. Okay. Now let's find the answer. So the function is increasing on this interval, and the function is decreasing on these 2 intervals, here to here, and here to here. Does it have a local maximums? Yes, local maximum will be this point. This is local maximum. The graph is like a down, up, down, down, up, down, right? So local maximum is here and here. This endpoint is local maximum, and this mountain is peak of the mountain is local maximum. Local minimum. You have 2 local minimums in the same region. Okay, those are local minimums. How do we find the y value here? Okay, how do we find the y value here? Well, you just plug in x value to the original function. Okay, so original function is this. So if you plug in this one into here, you're gonna get 0 and 0. And when you plug in 3, you're gonna get 9. And when you plug in -3, you're gonna get -9. So that's answers these questions. Okay. The same thing, we'll find the local minimums. Okay. And you need to find the extreme values. So where is maximum, where is minimum? So the highest, you just need to check by extreme value theorems. You just need to check these key numbers. And this is the largest among them. So this is gonna be absolute maximum. And this is gonna be absolute minimum. Okay. Oops. Hi. Okay, this is just a review question. What to find to solve the trig equations. I'm gonna skip this. Okay. Now, again, the similar question. Number 11. So identify the function's local extreme values in the given domain. F of t is 540t minus 5t cubed. And the domain is -7 through infinity. Okay. Now let's differentiate this one. Differentiate first to find the critical point. It's going to be 540 minus 15t squared. Let's factor out -15. I cannot factor out 15. Okay. Oh, yes, I can factor out 15. So -15 t squared minus 36. Okay. So the critical point will be when this becomes 0, right? So it's going to be 6 and -6. you have to be careful about the domain, whether these are included in the domain. And in this case, both of them are included. So both of them are the critical point for this problem. Let's quickly draw the increasing decreasing table. Domain is starting from -7 to critical values and goes to infinity. So the slope becomes 0 here, 0 here. And this is upside down parabola. It's quadratic function. So it's going to be negative, positive, negative in the order. So negative, positive, and negative. So original function is decreasing, increasing, and decreasing. Now, let's answer the questions now. So first one, find each local maximum. So local maximum, you have two local maximum here because down, up, down. So these 2 points are the local maximums. Well, so I need to find the y value at these 2 points. So I'm going to evaluate this one by plugging in -7 here. That sounds terrible. 540 times -7 minus 5 times -7 cubed. This is terrible. 3780 plus 1715. So it's going to be minus 2065. It just have too much work. Okay, and this one, this point, you're going to find f of 6. So it's going to be 540 times 6 minus 5 times 6 cubed, which is 3240 minus 1080, which is 2160. Okay. Now you need to find the local minimums. There is only one local minimum, fortunately, because this go ever. This does not have an endpoint, so this does not have a local minimum, but this is the local minimum point. So I need to find f of -6. But notice that this is just an odd function. So it should be same thing as f of 6 times -1. So by using symmetry, you can kind of save some time. It's -2160. Okay. Now you need to find extreme values. Does it have extreme values? Well, you know that this is a cubic function. And you know that the limit of this one gonna be -infinity. This goes to -infinity. That means this cannot be the absolute minimum. However, you should have an absolute maximum because you only have 2 options, and the larger one gonna be the absolute maximum. And the larger one is definitely this one. So the absolute maximum will be this. Okay. Okay, so this is another simple question, but I hope you can save some time by knowing the basic shape of this function. So I'm not going to draw and find the critical points and so on. I'll just tell you what this is. When you have a function looks like this, then you should know that this is a graph of the semicircle whose radius is r and center is at the origin. Okay. It is because it comes from the fact that x squared plus y squared is r squared is showing the circle. And when you solve this one for y, you're gonna get r squared minus x squared. When you take a square root of both sides, you're gonna get plus minus of this. And the plus side indicating the upper circle, upper semicircle, and the negative one indicating the lower half semicircles. So this function is actually a circle. And once you know that this is absolute maximum, local maximum, this is absolute minimum, local minimum, And this is absolute minimum and local minimum as well. So you should be able to answer these questions rather quickly if you know that this is a semicircle function. Okay. If you don't, then you will have to follow the same procedure like I explained in the previous section, previous program. Okay, this is just a review question. Find the derivative. And you can use the quotient rule. Remember the quotient rule? When you have a derivative of the quotient, then it's the bottom square, top derivative bottom minus top bottom derivative. 上分下マイナス上下微分割る下の2乗です。Okay, this is another review question. You just need to evaluate the inverse cosine function. Okay, inverse cosine function. So inverse cosine function, the range must be between 0 through pi. Okay, unlike inverse sine function, which has a range of negative pi over 2 through pi over 2. Inverse cosine has a range of 0 through pi. And the x coordinates become 1 over negative square root of 2 in this direction, right? So you know that this must be 135 degree, or in radian, it must be 3 pi over 4. Okay, this is just a review question about the tangent line. So it's not much to explain here, but just a review, okay? So first of all, let's find the equation of the tangent line at negative 3, 0. To find the slope of the tangent line, you find the derivative first. And I'm going to find the slope. Slope at x is equal to negative 3 is, you just plug in negative 3 to the derivatives. It's going to be 27 minus 9, which is 18. So slope is 18. Slope is 18. And the line goes through this point. So the equation of the tangent line is y minus y value is equal to slope times x minus x value. So that's going to be the equation of the tangent line. Okay, now looking at the graphs. Well, you know that xy equal to x cubed minus 9x is a cubic function with a positive coefficient in front of the cube. So its graph looks like this way, from lower left to upper right. So by looking at the choices, it's obvious that A and B is not the right choice. And comparing C and D, you notice that the slope of the tangent line is positive or negative. That's a huge difference. And we know that the slope is positive 18. So just pick a one with a positive slope tangent line. So D seems to be the only choice. Okay, now next question is interesting. You need to find another intersection point of the tangent line and the cubic function. So this cube function have a tangent line at x is equal to negative 3. And they eventually meet again at another point, and you want to know what this point is. So this is like an intersection point of two functions. So you can find the intersection of the x coordinate by setting up a system of equation like this. Okay, now this is equal to y. So eliminating y, you are going to get the cubic function like this. And that's going to become x cubed minus 27x minus 54. Now here's some tricks. If you know the Vieta's formula, and if you know that this must have a double root, the multiplicity of 2, then you can easily solve this equation to find another one. Okay. in Japanese、解と係数の関係、3次式のね、解と係数の関係知ってるとですね、3つの解をかけた数字っていうのは、この定数項に出てくるんで、それを利用してね、こっちの解が何なのかっていうのを見つけることができます。3つって言われても2つしかないじゃんって思うかもしれないけど、10回になっているところは答え2個分扱いなんですね。だからこの方程式の解は、2つはですね、マイナス3なんですよ。で、あと1個何なのって話なんですね。あと1個何なのってことなんです。でも、これとこれとこれかけたらマイナス54になるんで、じゃあここに来る数字って、いやもうマイナス6じゃんってわかるんだね。ということで、3つ目の答え、交わるところは6ってことがわかります。OK？ということで、この式ね、真面目に解くならね、マイナス3入れたら0になるってことだけは分かっているので、答えですからね。だから、so using a synthetic division or a long division to do this to divide it. Okay, divide it. Okay. Okay, and you can factor this one more. Okay, and you can get x minus 6. So this one, the x coordinate is 6. And once you find this, you plug in here, or you plug in here to find the y coordinate. Okay. Okay. Next question. It's just like a trig function. So number 16. So h of theta is equal to negative 2 cosine of theta over 2. But the domain is 0 through 2 pi. Now we want to find extreme values. So we want to know at which point it has a local maximum or local minimum by finding a critical point. So let's differentiate. Remember that the derivative of cosine is cosine of u. Derivative is negative sine u times the derivative of the inside by the chain rule. So it's going to be positive 2 sine theta over 2 times derivative of the inside, which is the slope of the line. So it's going to be 1/2. So derivative will be sine of theta over 2. Okay, so that's answer the first part. Now for what value of x, for what value of theta is this become 0? So now let's find the critical point. What is a critical point? So I need to solve this equation. Okay, sine becomes 0. Sine becomes 0 at these 2 points. So the inside, the angle must be a multiple of pi. Okay, 0, pi, 2 pi, 3 pi, and so on, where n is an integer. So that means theta must be a multiple of 2 pi. But since we have a domain restriction, 0 through 2 pi, so the only theta that's satisfying this and this is theta is equal to 0 or 2 pi. So those are the critical points. Okay, so that means this function have extreme values only at 0 or 2 pi. So now let's look at the table. Theta, h dash, and h. And this function has a closed interval in the domain. So left endpoint is 0, and the right endpoint is 2 pi, and there is no critical point in between. No critical point in between. So what is derivative is? The derivative is basically positive for any angles inside this interval because sine is positive in those intervals. So it's going to be positive here. So the function is always increasing. That means this must be absolute maximum and this must be absolute minimum. Okay. So you just need to evaluate what h of 0 is. So when x is 0, theta is 0, what is this? By plugging into here, you want to get -2 times cosine of 0, which is -2 times 1, so it's -2. Okay, so this is -2. Likewise, plugging 2 pi here, you're going to get -2 times cosine of pi. And the cosine of pi is -1, so it's going to be +2. So that answers those questions. Okay. It's asking for local minimum, local maximums. You know that the endpoint could be also a local minimum or local maximum point. So this is local minimum because it's the smallest point in that neighbor. And this is the local maximum because that's the highest point in that neighbor. Okay. Mini graphs here. Okay, sketch the graph of the differentiable function y is equal to fx through -5, 5 if f dash of -5 of 0 and satisfies the following. So you have 4 different questions, and I'm gonna just answer A and C, okay? So part A. So it's a differentiable function. And we know that f dash of -5 is 0, and y value when x is equal to -5 is 5. Okay. Now in the first part A, so f dash is positive in this interval, and f dash is negative in this interval. So the graph must be increasing to the point -5, 5, then decreasing after -5, 5. So looking at the choices, so I need to find the graph that goes through -5, 5, which this C doesn't show anything about -5, 5. B doesn't show it either. Part A and part D shows -5 and 5. And which one shows increasing, decreasing? A is only choice. D is not. Okay, so A is the right choice. Now look at the choice C. So choice C said f dash is positive for any x not equal to -5. So for the part C, the only difference is here. Okay, so if x is not equal to -5, the slope is, the f dash is always positive. So this becomes positive. So that means this is gonna be increasing as well. So increasing, rest, increasing. So graph looks like this. Okay, increase, rest, increase. That kind of graph. So looking at the choice C's, C and D looks the better choice because of the shape, increasing, stop increasing. But the C is going through the 0.55, but D is going through -5, so D is the best choice. Okay. Okay, so next question is similar. I hope you can work on this one. So I'm gonna skip this. Okay, this is just like application of what we have covered in this section for the quadratic functions. Okay. So assume we have some basic quadratic function. So a is not equal to 0. Okay. So to find that it's increasing or decreasing, you're going to differentiate this function and you're going to get 2ax plus b. And let's find the critical points. You solve for x and you're going to get x is equal to -b over 2a. So that's going to be the critical point. So this is only critical point in all real numbers. And now you want to check what is the slope here. Okay, so you have two cases. If a is greater than 0, if a is greater than 0, then this is a line, increasing line. So it's going to be slope is changing from negative to positive, right? So you're going to have decreasing, increasing in the order. Okay. So on the interval negative infinity through negative b over 2a, the function is decreasing. And from negative b over 2a through infinity, the function is increasing, as we expected, because it's a parabola, right? With a is greater than 0. And when case a is less than 0, this line has a negative slope. So line looks like this. So the sign gonna be changed from positive to negative. So everything gonna switch. So it's gonna be like this. Okay, as we expected. In case a is less than 0, the parabola is concave downward, and that's it. So basically, if you know what the calculus is, you can find the vertex of the parabola, and you can check increasing, decreasing part of the parabola as well. So you don't need a completing square method. Okay, last question. Find a quadratic function that goes through 2, 0 and has a local minimum of 0, negative 1. So this is just like a quadratic function problem, so we don't need the calculus techniques, but let's use a calculus technique. Okay, so we know that when x is equal to 2, y is equal to 0. But also that the important part is when x is 0, y is negative 1, and that's the local minimum. So let's differentiate this. And the critical point is negative b over 2a. Okay. And at that point, the derivative is 0. And this is a local minimum, local minimum. This is local minimum. So from this, you know that the graph must be down and up instead of up and down. So here it must be down and here must be up. So the slope must be like, f dash must be negative, then positive. And this point is when x is 0, when x is 0. So this must be 0, okay? And this must be negative 1. So you got the two equations. So the critical point is x is equal to 0. And the y value at x is equal to 0 is negative 1. So f of 0, which is c, must be negative 1. So those are the two informations. And another information we have is f of 2 is equal to 0. F of 2 is, you just plug in 2 to the original equation. So it's going to be 4a plus 2b plus c is equal to 0. Now you have a system of equations with 3 unknowns. So you should be able to solve for a, b, c. Okay. Now from equation 2, it's obvious c is equal to negative 1. And from 1, it's obvious that the b must be 0. And combine those two, this becomes 4a minus 1 is equal to 0. So a must be 1 over 4. So the answer is f of x is equal to ax squared plus bx plus c. So it's going to be 1 over 4x squared minus 1. Okay. So that's complete explanation for section 4.3. Next time I'm going to cover section 4.4. Okay. Thank you for listening.